Imagine for a moment that you've been promoted, but it's not just any promotion.
Oh.
You aren't being asked to manage a team of 5 people. You aren't even being asked to manage a division of 500 people. You have just been handed the keys to a workforce of 500 artificial intelligences.
That is a thought that would keep most people awake at night.
It sounds like absolute chaos, doesn't it? I mean, we're all used to chatbot experience by now. You ask a bot to draft an email, it drafts the email.
Oh, it's responsive.
Totally responsive. You ask it to summarize a PDF, it summarizes the PDF. It just sits there, blinking a cursor, waiting for you. It's a tool. It's a hammer.
Mm-hmm.
But now I want you to imagine that instead of one assistant waiting for orders, you have 500 entities that aren't waiting. They are holding meetings. They are assigning tasks to one another.
Wow.
They are reviewing code, debating strategy, running complex national simulations. And you are just sitting back, watching the logs scroll by, hopefully with a coffee in hand.
That is exactly the shift we are unpacking today.
Mm-hmm.
We're moving away from the era of the chatbot, which is essentially a singular responsive tool, and entering this new frontier of multi-agent systems, or MAS.
MAS, right.
And the fundamental question has changed. It is no longer, can the AI do this specific task for me? It is now, what happens when I stop managing the AI and the AI starts managing itself?
That is the core of today's deep dive. We are looking at the difference between having a hammer in your hand and having an entire construction company at your command.
That's a great analogy.
And to do this, we are going to dissect 2 absolutely groundbreaking papers that tackle this new reality from opposite ends of the spectrum. It's like looking at 2 sides of the same coin, and that coin is autonomy.
Precisely. On one side, we have the logistical nightmare of autonomy. How do you actually coordinate a digital workforce of that size without it turning into a digital riot?
A digital riot, I like that.
And that brings us to our first paper, Mega Agent. This research comes out of a massive collaboration, including the National University of Singapore, and they are laser-focused on execution and scale.
And when we say scale, we aren't talking about a dozen agents chatting in a circle.
No, not at all. They are pushing the boundaries up to nearly 600 agents working in parallel. They are trying to solve tasks that would shatter a normal system, essentially asking, how do we build an army?
Okay, an army. And then on the flip side, we have the internal struggle of autonomy, because once you have this army, how do you ensure they are actually smart enough to do the job?
Exactly.
You can't handhold 600 agents. You can't teach them everything one by one. And that's where the second paper comes in, Multi-Agent Evolve, or MAE.
MAE is fascinating because it shifts the focus from doing to learning. It's about a single large language model splitting its own personality into different roles.
It's like it's developing a productive form of multiple personality disorder.
That's a perfect way to put it, yeah. It's designed to train itself. It grades its own homework and gets smarter without a human ever, checking the answers.
So it's a move from artificial intelligence to artificial organizations. So our mission today is clear. We are going to unpack how AI is graduating from a tool that waits for instructions to a system that organizes itself, sets its own rules, and runs its own show. Let's start with the logistics. Let's talk about the manager of the group, Mega Agent.
Let's get into it.
To really appreciate what Mega Agent is doing, I think we have to look at the status quo. Because multi-agent systems, they aren't brand new. We've seen things like MetaGPT or ChatDev.
Sure, they've been around.
Yeah, they have been around for a little while, and they are pretty cool. So why can't I just spin up 500 instances of MetaGPT and call it a day? What breaks?
The problem is what we call the bottleneck of coordination. You see, systems like MetaGPT or ChatDev are brilliant proofs of concept, but they are often incredibly rigid.
Rigid how?
They rely on what's known as SOP, Standard Operating Procedures.
SOPs. That sounds like corporate bureaucracy at its finest.
That is exactly what it is. In most current multi-agent systems, the human developer has to predefine the workflow. You have to write a script that says, okay, Agent A, you are the coder. Agent B, you are the reviewer. Agent A sends code to Agent B.
So it's a fixed chain of command.
Completely fixed chain.
Right.
If Agent B rejects it, it goes back to Agent A. It's a linear, hard-coded chain.
So it's like a scripted play. Everyone has their lines and they can't deviate. If the coder wants to talk to the marketing guy, but the script says he can only talk to the reviewer, he's just stuck.
Exactly. And that works fine if you have a team of 3 or 5 agents doing a repetitive task like write a snake game.
Right. Simple stuff.
But imagine trying to script a play with 500 actors. where you don't even know the plot yet. It falls apart instantly.
Instantly.
If the task is complex, say, simulate the economic policy of a developing nation, you cannot pre-script every single interaction. The human user becomes the bottleneck because they have to design the architecture for every single specific task.
Right, because if I have to spend 3 hours designing the workflow for the agents to do the job, I might as well just do the job myself. It completely defeats the purpose of automation.
Correct. And that linear chain is also incredibly slow. If Agent A has to finish before Agent B can even start, you aren't really getting the benefit of a swarm. You're just getting a very slow single-file relay race.
Okay, so that's the problem. The old way is rigid, it's slow, and it puts all the work back on the human. So how does Mega Agent solve this? If they aren't using a script and they aren't using a linear chain, how do they know what to do? How do you keep 500 agents from just yelling at each other or hallucinating in a corner?
This is where the authors made a brilliant leap, a really clever move. They took inspiration from the one system that handles massive parallel complexity every single day.
And that would be,
The operating system on your computer.
you mean like Windows, Linux, macOS?
Exactly. Think about how your computer works right now. You are running a web browser, a recording software, maybe a music player, and background updates are happening.
All at once.
All at once. And you, the user, do not tell the CPU, okay, now process the audio byte, now process the pixel on the screen, now send the data packet. You don't manage the electrons. The operating system manages processes and threads.
Okay, let's break that analogy down because I think it's crucial to understanding how this works. It feels like the central idea. In the context of Mega Agent, what is a process?
A process is a large task. Let's say your prompt is build a full Go-Bang strategy game. That entire prompt, that's the process. The system treats this as a contained entity with a specific goal and its own memory space.
Okay, that makes sense. And the threads, what are they?
The threads are the subtasks handled by specific agents. And just like in a computer, a process can spawn multiple threads that run at the same time.
So they're running in parallel.
They run in parallel,
Yeah.
and they talk to each other through message queues, a producer-consumer model, rather than passing a baton one by one. One agent produces a piece of code, puts it in the queue, and a reviewer agent consumes it when it's ready without them having to wait on each other directly.
So Mega Agent is essentially treating LLM agents as if they were computing threads. It's abstracting the management away from the human. I'm not the manager anymore. The OS is.
Yes. And to manage this, they built a hierarchical structure that, well, it mimics a large corporation. At the very top, you have the boss agent.
The CEO, the big cheese.
The CEO, exactly.
Mhm.
The boss agent takes your prompt, which they call the meta prompt, and breaks it down. It decomposes the big scary task into manageable chunks.
Okay.
But here's the key difference. The boss doesn't do the work. The boss is a delegator. It assigns those chunks to admin agents.
Okay, so we have middle management. I feel like middle management gets a bad rap in the real world, but in this case, they sound pretty necessary.
In this system, they are vital. These admin agents are autonomous. In a standard system, that SOP trap we talked about, the admin's role would be fixed. It would just be a pass-through. But in Mega Agent, the admin agent looks at the subtask and makes a decision.
What kind of decision?
It asks, is this too big for me? If the task is build the user interface, the admin agent might realize that's actually 3 jobs: designing the layout, writing the button logic, and creating the graphics. So if it's too big, the admin agent dynamically recruits ordinary agents to help.
Wait, recruits, like it hires them on the fly.
On the fly. It forms what they call a dynamic group. If the task is write the code for the game board, and the admin realizes it needs a graphics handler and a logic handler, it spins up 2 agents specifically for those roles. It gives them their personas, sets them to work, and then it monitors them.
That is wild. So it's not a fixed team, it's like a gig economy inside the software. The admin agent sees a need, spins up the talent, gets the work done, and then what happens to the group? Do they just hang around?
Nope. Once the task is verified and complete, the group dissolves. The agents are freed up, or rather the computational resources are freed up. This is incredibly efficient.
It has to be. That solves the rigidity problem completely. But I want to go back to that no SOP rule. If there's no script, how do they avoid chaos? I mean, 500 agents without a script sounds like a recipe for a very noisy digital riot. If I just tell 500 people, go build a house without a blueprint, I'm going to end up with a pile of wood and a lot of injuries.
It does sound risky, but they replace the rigid SOP with what they call autonomous task decomposition and rigorous monitoring. They trust the LLM's inherent reasoning capabilities to figure out the how, provided the what is clear.
Okay, but trust only goes so far with these things.
You're right. You can't just trust blindly. That leads to their system of checks and balances, which is probably the most important part of the architecture.
The quality control department.
They call it hierarchical monitoring, and it mirrors the management structure we just discussed. It's multi-layered. It starts at the bottom. Every single agent has an agent-level monitor.
So it checks itself.
It's essentially a self-check mechanism. Before an agent says, "I'm done," it has to run through a checklist verifying its own progress. It asks itself, did I meet all the requirements of my assigned task?
So they grade their own homework before turning it in. Did I actually write the code? Does it compile? Did I answer the prompt?
Exactly. Then you move up a level. You have group-level monitoring. The admin agent watches its recruits. It ensures that what the graphics agent is doing actually matches what the logic agent is doing. It's looking for coordination failures.
So it's the project manager making sure the parts fit together.
Right. It detects if they are hallucinating or drifting off topic. And finally, you have system-level monitoring, where the boss agent looks at the final integrated output to ensure it matches the user's original request. It's the final sign-off.
It really is a corporate structure. You have the individual contributor checking their work, the manager checking the team, and the CEO checking the final product.
And because this structure is generated dynamically, it's incredibly flexible. You don't have to redesign the company for every new project. The system designs itself based on the complexity of the prompt. If the prompt is simple, maybe you only need one admin and 2 agents. If it's complex, you get the full army.
Okay, the theory is sound. It's an OS for agents. It's a self-building company. But let's talk results. The paper mentions 2 big case studies that prove this actually works. I want to dig into the first one, the Go Bang game. For those who don't know, Go Bang is basically Connect 5 on a Go board.
Correct. It's a strategy board game. Now, writing a fully functional game from scratch, GUI, logic, win conditions, mouse clicks, it's a classic benchmark for coding agents. It's simple enough to understand, but complex enough to break things.
So who are they up against?
The researchers pitted Mega Agent against the big names, MetaGPT, ChatDev, and other state-of-the-art frameworks.
And what happened?
Well, this is the really impressive part. Mega Agent developed a fully functional Go Bang game in under 800 seconds.
Wow. Okay, so what's that, like 13 minutes?
Roughly, yeah, just over 13 minutes from a single prompt to a working application. But here's the kicker.
Okay.
It was the only model to successfully complete the task.
Wait, the others failed. Like they couldn't do it at all.
They failed or they timed out. The baselines struggled with the complexity. They would get stuck in these endless loops, or the code wouldn't compile, or the agents would just lose track of the context.
So what was going wrong for them?
One agent would write the board logic in Python. Another would try to write the UI in a completely different framework, or they just couldn't integrate the pieces. They'd have a working game logic but no way to display it, or a beautiful display that did nothing.
So they couldn't get the different parts to talk to each other.
Precisely. Mega Agent's dynamic grouping meant it could isolate the board logic, the UI, and the win conditions into parallel tasks, into separate threads, and then the admin agent's job was to merge them successfully at the end.
That is a massive flex. We did it in 13 minutes and you guys didn't finish. It really highlights that process and thread isolation. By treating the UI as a separate thread from the game logic, they don't get confused.
Exactly. But the second case study is the one that really blew my mind regarding scale, the national policy simulation.
This sounds significantly more complex than a board game. What exactly were they simulating?
The task was to generate comprehensive policies for a nation across multiple domains simultaneously. We're talking tax policy, education reform, healthcare infrastructure, and economic regulation.
Well, those are all deeply interlinked.
Massively interlinked. If you change taxes, it affects healthcare funding. If you change education, it affects the long-term economy. You can't just solve for one variable in isolation.
And this is where they scaled up to hundreds of agents.
Yes. For this task, Mega Agent spun up approximately 590 agents to handle it.
590. Just think about that number for a second. That is a battalion. That's a small company.
And to give you a comparison, the baseline models they tested against, the SOP-based ones, could barely coordinate fewer than 10 agents before breaking down. They just collapsed under the weight of the context.
What happens when you try to give a task like that to just 10 agents?
They get overwhelmed, they hallucinate, they forget previous instructions, or they just produce generic fluff because they can't hold all the context. They'll say something like, to improve healthcare, we should improve healthcare. It's useless.
So Mega Agent had, what, specific groups for everything? Like an agent for traffic lights and an agent for school lunches?
Pretty much. The granularity was incredible. You can imagine I had specific subgroups for high-income tax policy, banking regulations, rural school districting, hospital staffing.
So you could have an admin agent for healthcare.
Right, and that admin agent for healthcare recruits a specialized hospital infrastructure agent and a drug pricing agent. They work in parallel, doing their deep dive, and then the admin agent combines their reports into a coherent healthcare policy.
It proves that the OS approach treating agents like threads is the way to go for scale. You don't micromanage 590 threads, the OS does it for you. You don't sit there and assign tasks to the drug pricing agent yourself. You just tell the boss, fix healthcare.
Precisely. It eliminates the human bottleneck. You give the goal, and the system builds the organization required to achieve it. It scales in width. If the problem is wider, the system just gets wider to match it.
So that's Mega Agent. It's the ultimate manager, the OS for AIs. It takes a stack of work, builds a team, and gets it done. But, and there's always a but, having 590 agents is only useful if those agents actually know what they're doing.
Right. A large organization of incompetent people is just a large disaster. A very efficient disaster, maybe, but still a disaster.
Exactly. If I have 590 interns who don't know anything about tax policy, I'm not going to get a good tax policy. I'm going to get a mess. I want a smart organization.
And that is the perfect segue to the other side of the coin. That brings us to Multi-Agent Evolve, or MAE. This paper shifts our focus entirely. We are leaving the world of execution, getting things done, and entering the world of learning, getting smarter.
So the premise here is self-improvement. We hear about reinforcement learning, or RL, all the time. AlphaGo, ChatGPT, they all use it. Why is this paper different? What's the specific problem they are trying to solve?
The problem is what we call data starvation, or more specifically, the lack of ground truth in general domains.
Okay, let's unpack ground truth, because that sounds like a philosophical concept.
It is, in a way. Traditional reinforcement learning, the kind that powered AlphaGo, works best when you have a clear, objective signal of right or wrong.
A scoreboard.
A scoreboard, exactly. If the AI makes a move in a game of Go and eventually wins the game, that's a +1 reward. If it loses, it's a -1. Or in coding, if the code compiles and runs, that's a reward. The universe gives you a thumbs up or a thumbs down. There's no ambiguity.
Right. It's easy to grade a math test or a chess match. There is an objective reality. You either won or you lost. Your code either ran or it didn't.
Exactly. But what if you want to train an AI to be better at creative writing, or nuanced reasoning, or answering why is the sky blue in a way that a 5-year-old understands?
Or debating ethics.
Debating ethics. Perfect example. There is no compiler for that. There is no simple scoreboard. What's the ground truth for a good poem?
You usually need a human to read it and say, yeah, that's pretty good, or no, that's terrible.
And that brings us back to the bottleneck. Human-labeled data is expensive, it's slow, and it's hard to scale. We can't have humans grading billions of essays. If we want AI to get smarter than humans, it eventually needs to learn without us. It needs to grade its own homework.
But how do you grade yourself without cheating?
That's the paradox. If I grade my own test, I'm giving myself an A+ every time. Good job, me. You nailed it. There's no learning signal.
So how did they solve it?
The researchers behind MAE solved this by developing a framework they call the triad. They take a single large language model. In this case, they tested with Qwen 2.5 3B Instruct, and they instantiate 3 distinct roles from that one brain.
The 3 musketeers.
Or perhaps the good, the bad, and the judge. The roles are the proposer, the solver, and the judge.
Okay, let's meet the cast. Who is the proposer?
The proposer is the challenger. Its role is to generate questions. But, and this is critical, it isn't just asking random questions from a textbook. It is rewarded specifically for finding questions that are difficult for the current solver to answer.
Oh, so it's a troll. It's actively trying to stump the other agent. Its job is to find the weak spots.
In a way, yes. It's looking for weaknesses. It probes the knowledge boundary. It's the sparring partner that doesn't let you get comfortable. But it can't just generate nonsense. It has to generate questions that are actually solvable and high quality. Otherwise, the judge penalizes it.
Okay. And the solver. That one seems obvious.
The solver is the student. Its goal is simple. Answer the question and satisfy the judge. It is trying to maximize its score. It has to adapt to whatever curveballs the proposer throws at it.
And finally, the judge. The referee.
The judge is the evaluator. Since we don't have a human, the judge uses a chain of thought process to analyze both the solver's answer and the proposer's question. It grades them on a scale of 1 to 10 based on strict rubrics for correctness, logic, and clarity.
So wait, it judges the answer and the question.
Yes, and that's crucial. It evaluates the answer. Did they get it right? Was the reasoning sound? And it evaluates the question. Is it actually solvable? Is it well posed? Is it a high-quality question? This prevents the proposer from just asking gibberish to confuse the solver.
So the solver is trying to please the judge, and the proposer is trying to stump the solver, but still get a thumbs up from the judge that the question was fair.
Exactly. It creates a closed-loop training system.
Yeah.
And this leads to a fascinating psychological effect the paper discusses called desirable difficulty.
Desirable difficulty, I like that term. It sounds like something from a workout routine. No pain, no gain.
It's actually a concept from educational psychology. Think about how you learn best. If I give you math problems that are 2 plus 2, you don't learn anything. It's too easy. You're bored. You zone out.
Right. My brain isn't engaged. I'm not growing.
Now, if I give you advanced quantum mechanics equations right now, you also don't learn anything. It's too hard. You just give up. You don't even know where to start. It's demotivating.
I need the sweet spot. Hard enough to stretch me, but solvable if I try.
Exactly. That is the zone of proximal development. In this system, the proposer evolves to find that zone. As the solver gets smarter, the easy questions don't stump it anymore. So the proposer stops getting rewarded for them. It has to invent harder, trickier questions to get its reward.
And that forces the solver to get smarter to keep up.
Right. They push each other up the ladder of intelligence. It's this beautiful, self-perpetuating cycle of improvement.
It's an evolutionary arms race, but they're on the same team. They are wrestling each other to get stronger.
Perfectly put. That's the core engine of MAE.
Now, you mentioned the mechanics of this. How do they actually update the AI's brain? Because if they are all the same model underneath, doesn't that get messy? If the proposer learns to be mean, does the judge become mean too?
It can. And that is a huge technical hurdle they had to overcome. They use a technique called task relative reinforced plus line. It's a bit of a mouthful, but the concept is elegant.
Break it down for us.
Okay, so since all three agents, proposer, solver, judge, are technically coming from the same base model weights, you have to be careful. You don't want the proposer personality, the troll, to bleed into the judge personality. You don't want the judge to start getting competitive or the solver to start asking questions instead of answering them.
Right, the judge needs to stay neutral. The roles have to stay distinct, even if the brain is shared.
So Reinforce++ is a clever algorithm that calculates the advantage. How good was this move compared to the average? For each role independently. It creates 3 separate learning signals. Then it synchronizes the updates to the main model in a way that preserves the distinct capabilities of each role.
So it's like 3 different specialists are training the same athlete. The strength coach works on muscles, the nutritionist on diet, the psychologist on focus. The whole athlete gets better, but the coaching remains separate.
That's a fantastic analogy. It effectively compartmentalizes the skills while sharing the general intelligence.
So the whole brain gets smarter even though the roles are distinct. But I have to ask about the risks here. We've seen AIs hallucinate, we've seen them drift. What if the proposer starts asking nonsense? Why is the moon made of cheese? Or the judge just starts giving everyone 10s because it's lazy? Or because it found a loophole?
That is the biggest risk in self-play systems. Model collapse, or training on garbage. If the signal gets noisy, the whole thing can spiral down into uselessness very quickly.
Right. Garbage in, garbage out.
MAE combats this with 2 clever mechanisms: quality filtering and format rewards.
Format rewards, like giving it a cookie for using the right font?
Close? It's about structure. They reward the agents for using the correct HTML tags, like question or score. This sounds really trivial, but for an automated loop, it's vital. If the judge writes a beautiful, insightful essay about the solver's answer, but forgets to put the final score in the score tag, the math doesn't work. The gradient update fails.
The machine breaks.
The machine breaks. So they explicitly incentivize coloring inside the lines to keep the whole automated system running smoothly.
And the quality filtering.
That's the judge's other critical job.
Yeah.
Before a question from the proposer is even accepted into the training set, the judge evaluates it for quality. It asks, is this solvable? Does it make sense? Is it actually a question, or is it just a random string of words?
So it's a gatekeeper.
It's a gatekeeper. If the quality score for the question is below a certain threshold, say a 7 out of 10, it gets tossed.
Yeah.
It never enters the training data.
It's the immune system of the AI, killing the bad data before it can infect the brain.
Exactly. This ensures that the desirable difficulty curve stays on track and doesn't veer off into hallucination land.
So does it work? We have the theory, we have the triad, we have the safeguards. What were the results when they actually ran this?
The results were very impressive. As I said, they tested this on Qwen 2.5 3B Instruct, which is a relatively small model, and across a wide range of benchmarks, math, coding, general knowledge, MAE, achieved an average improvement of 4.54%.
4.5% might sound small to some listeners. I got a 4% raise, woo! But in the world of LLMs, gaining nearly 5% across the board without feeding it terabytes of new external data is a massive jump.
It is huge. It's the difference between a passing grade and an honors grade on these benchmarks. Usually to get that kind of jump, you need a whole new model architecture or a massive new data set that took months of human effort to create. This was done autonomously.
Wow.
But the most telling result came from what they called the zero setting.
The zero setting. This is the one that sounds like sci-fi to me.
It's pretty close.
Yeah.
In this setting, they started the model with just 16 seed questions. That's it. No massive data set. Just 16 examples to show the AI the format of a good question-answer judgment triplet.
So basically just a prompt.
Basically a prompt. And from that tiny seed, the model generated its own questions, graded its own answers, and improved itself significantly, beating a baseline called AZR, which is another self-play method.
It pulled itself up by its own bootstraps. It started with almost nothing and taught itself to be smarter.
Yes. It spun knowledge out of reasoning.
Yeah.
And here's a nuance the paper highlights that I found really insightful. The absolute best results came from the half-reference setting.
Okay, what's that?
That's where they mixed completely new self-generated questions with variations of existing human questions from a data set.
A hybrid approach.
A hybrid approach. It turns out having a little bit of guidance, a syllabus, if you will, helps the proposer find that desirable difficulty sweet spot faster than if it's purely exploring the unknown.
That makes perfect sense. Innovation is good, but knowing the basics helps. It's like a jazz musician. You can improvise all you want, but you need to know your scales first. The human data gives it the scales.
Exactly. It shows that while the AI can learn from zero, this hybrid approach of human-seeded concepts plus AI evolution is currently the most powerful engine for improvement.
So let's zoom out. We've covered a lot of ground. We've got Mega Agent, which is the extroverted manager scaling out to build empires. And we have MAE, the introverted philosopher, meditating in a gym to get stronger.
That is a beautiful way to visualize it. I'm going to steal that.
So if we look at these two papers together, what is the bigger picture? What's the major takeaway from seeing these two approaches emerge at the same time?
The bigger picture is the divergence of scalability. We usually think of scale as just bigger models or more data. But here, we're seeing scale in two new and frankly more interesting dimensions. Mega Agent gives us scalability in width.
Width.
Yes, the ability to tackle wider, more complex tasks by just adding more agents. If the job is too big, you widen the workforce. You add more threads. You don't necessarily need a single super genius agent to run a national simulation. You need more agents organized better.
Okay, that's Mega Agent and MAE.
MAE gives us scalability in depth, the ability to deepen the intelligence of the individual unit without needing a human to hand-feed it wisdom. It makes each individual agent more capable of handling nuanced, complex reasoning.
And I noticed a contrast in their management style, too. It's really striking. Mega Agent has a boss, MAE has a judge.
That's a key distinction. The Mega Agent boss is an executive. It's a CEO. It cares about task decomposition and completion. Did we build the game? Did we write the policy? It focuses on output. It's pragmatic.
Get it done.
Get it done. The MAE judge is an academic. It's a professor. It cares about quality. Was the reasoning sound? Was the question logical? Was the answer well explained? It focuses on process.
One gets the job done, the other ensures you're smart enough to do the job right in the first place.
Correct. And both of these approaches, at their core, rely heavily on the death of the human in the loop.
We talked about the SOP trap earlier. The implication of Mega Agent is really the end of the standard operating procedure as a human task. We're not writing the playbook anymore.
We're not. We are moving from human in the loop, where we are a gear in the machine, turning the crank, to human on the loop. We set the destination, and the machine steers the ship. In Mega Agent, the human gives the meta prompt. In MAE, the human maybe provides a few seed questions. After that, the system takes over.
It's empowering, but also a little terrifying. Because autonomy means they can make mistakes we don't see until it's too late. If the boss agent decides the best way to fix the economy is to ban ice cream, and the 590 agents execute that flawlessly.
We might not know until all the ice cream shops start closing.
Exactly.
Which is why both papers, and it's so important, they emphasize their internal monitoring so heavily. Mega Agent has the interaction check and the checklists. MAE has the quality filtering. Both sets of researchers realized that in a multi-agent world, bad data or hallucinations are like a virus. They spread fast.
It's contagion.
It is. So building a robust immune system agents, whose only job is to check other agents, is going to be absolutely critical for these systems to be reliable.
It's fascinating that in MAE they did an ablation study, basically turning off parts of the system to see what breaks. And they found that if you turn off the training for just one role, like if you stop the judge from learning and evolving,
the whole system degrades.
the whole thing falls apart.
Right. It's all or nothing. You need the creativity of the proposer, the logic of the solver, and the critical eye of the judge evolving together. Diversity isn't just a nice-to-have feature. It's mechanically essential for the system to learn.
It's like a three-legged stool. You kick one leg out, it's over.
Exactly. If everyone agrees, no one learns. If the judge is too nice, the solver stops trying. If the proposer is too easy, the solver gets bored, and its intelligence stagnates.
If everyone agrees, no one learns. That's a bumper sticker for AI development right there.
It really is. It's a lesson for humans, too, honestly.
Okay, we're coming to the end of our deep dive. We've seen the future of execution with Mega Agent's 590 agent army. We've seen the future of learning with MAE's self-improving triad. So, what happens when these two meet?
That is the final provocation, isn't it? That's the billion-dollar question.
I mean, just try to picture it. You take Mega Agent's architecture, its ability to spin up an army of 590 agents, but instead of just being standard, off-the-shelf models, every single one of those 590 agents has been through the MAE gym.
It's the convergence. You would have an organization that scales infinitely in width to handle any complexity, composed of individuals who are scaling infinitely in depth to handle any difficulty.
And they wouldn't just be executing your plan anymore, they would be critiquing it, improving it. Maybe the proposer agent in the group says, hey boss, this plan to build a Go-Bang game is too easy. Let's try something harder. Let's not just simulate the economy. Let's build a model that optimizes it for social good.
You move from artificial intelligence to artificial organizations that are self-correcting, self-managing, and self-improving. At that point, the human role isn't even on the loop anymore.
What are we then?
We might just be the shareholders. We give the initial investment, set the mission statement, and then watch the quarterly reports come in.
The shareholders of our own digital companies. Well, on that slightly existential note, that's a wrap for this deep dive.
It's a brave new world we're heading into.
It certainly is. Thanks for listening, everyone. Keep learning, and maybe start thinking about what your 590 agents are going to do. See you next time.